Hello, good afternoon. And Zubi, do you want to stay here with me? Maybe? No? What? Come here. Okay, hold on. I've got a Zubi who wants to be held, apparently. So anyways, yesterday afternoon, we finished the exploration of genetic programming, which may have actually been evolutionary programming with a very subtle difference that I'm not aware of really what that is. Yes, we're going to be doing gene splicing again. Also, hello, Jim. How are you today? Yeah, we're going to be creating X-Men, clearly. Although not, because I think that would get me sued. Because Disney owns them now. All right, are you done being pet? Okay. Do you want to stay here? No? Okay. That's evolutionary code? Yeah, that's the idea. Evolutionary code. Also, hello, Andrew. How are you both doing today? Happy time zone, everyone. Happy time zone to everyone. Okay, well, apparently Zilby did not want to hang around for this. Daddy, hello. Yeah, so yesterday afternoon, actually the last 3 afternoon streams, or was it just 2? The last several afternoon streams, we've been doing evolutionary programming with well, Python and Rust together. Sort of like learning that. Owen Xanax, hello, welcome, and also thank you so much for the subscription. Thank you. 4 months already. How's your day going? So yeah, we followed a tutorial to use an evolutionary algorithm to basically solve or like figure out what a random string was that we created. And so now I want to sort of like start walking myself up the Bloom's taxonomy. So if you're not familiar, this is really cool. It gets into a little bit of educational theory. Do I have this already? I mean, this has some education stuff. So let's just rename this educational theory. It's not this. We're gonna do something else. So in Bloom's taxonomy, we have a triangle, and there are steps along the triangle. So things like these. I can't remember off the top of my head how many steps there really are in each one, so you'll have to excuse me if I get it wrong by a couple of them. The middle ones like aren't like really too super important for what I'm trying to explain right here, but the idea is that down here we have basically just memorization, and what this really means is that you tell me what to do and I just do it. I don't understand, I don't know what it is, we just do it. Can you link this article from yesterday? Yes, I can go ahead and find the tutorial that we were using. Is that the right? Yeah, this is the right. It was like tech.io. Okay, this is the beginning of the article. It is okay. It has many of the faults of most teaching out there that I've seen, especially in a machine learning, which is that it suffers greatly from, and now do the rest of the OWL. But the first part, so in encoding and tools, those two are actually pretty good. Algorithm is sort of a, okay, now do the rest of the OWL thing, and it doesn't give you good feedback on whether or not it works. But it got us far enough along that we were able to get it working in Rust locally. Also, this is all Python, so just a heads up. You know that AI training was based on an actual human brain? Oh, I forgot their name already. Let me look it up. If Nick Maffei was here, Nick might be able to elucidate, basically let us know if that's like fully correct. From my very basic understanding, most of AI training, there's this huge like big circle in like machine learning, and there's a bunch of different things in there, and some of them are based upon human brains and how we work, but I think some of them are based, like the one we're doing today is based upon like evolution type stuff instead of just focused on human brain. So it's a very different style of machine learning. Like, for example, I don't think that you would use evolutionary programming to create and run an LLM. Like most things, it depends. Yeah, exactly. It depends. That's a good way of putting it. It depends. You could probably use ChatGPT to ask for the difference between the different types of machine learning, and it would probably do a decent job because there's probably a million articles out there that's been trained on that do that. The problems that I've noticed with most training for these is that they rely upon you having skills in different areas. Like, for example, I remember thinking, oh, I really want to learn this machine learning. I really want to learn like AI type stuff. And so I watched a few videos, even watched like some of the Jabril stuff, code bullet things, like, they're all really cool. I want to do those. And then there's a lot of, okay, well, here's how to get into it. Go all learn theory and like math and all these other things from this completely different area. And while that, yes, that would work and get you there, that to me, that's not the best way, because that's a lot of work up front. And the reward for all that work is now I unlock the ability to learn the thing that I really wanted to learn the entire time. This tutorial was slightly different. It basically just said, you don't have to really understand what we're doing. Just do this thing. Just memorize this. And that is the memorization thing. Now, what we want to do is we want to get up here to the top, which is invention. And invention is where we are able to basically take the ideas of how this entire thing work and like reinvent our own version of it, and basically say, okay, well, I want to do this thing that either hasn't been done or I haven't like directly seen of how to do it, but I can create a way to do it in my mind. That requires true understanding of how things work. And that means that somewhere up here, and then I sort of like, it makes it not really Bloom's taxonomy. I kind of like have my own mental model of like uses Bloom's as like a guide essentially, where it's like, okay, well over here, I need, this is like, we need like build and burn. It's a thing that I call, which is recreate the same thing, but in slightly different contexts, just very slightly different contexts. The burn part is that this is a thing that I don't care about. I don't like, this is not going to be something for production. This is not something for, anything else. It's just going to be, we need to do that. And then in the process of doing this, a beautiful thing happens called transfer. And transfer contrary to the common perception of it, of like transferring knowledge from like an article or a teacher or somebody else to you as a student, transfer really means transferring your knowledge from one domain to a different domain, but it's the same problem. And that leads to understanding. So if you think about it, like this entire thing is all understanding. And so transfer is how I can like move myself up. That's a little bit, that's your daily dose of educational theory. You got data from an article and you convert it into knowledge. Yeah, that's a good way of putting it. So here is my plan for this. We are going to play around. We're going to do the like pretty much the same type of problem. In my mind, and for those of you who actually know evolutionary programming, you have done this before, you know what you're doing, please feel free to jump in and, you know, correct me or let me know like if what I'm saying is like even close to even if it's close to wrong, I want to know. Right is right, as they say. I want to recreate, I felt like I created like a single dimensional organism. Like it had one thing, it did one thing. So I want to kind of start with that and start building on it and making it more complex. This is not really going to be a build and burn. I'm not going to like redo that one over and over and over again. But instead what I'm going to do is build a small thing and start building on top of it. So I want to recreate what we did, but in a different format. So single different task that it does. So it's like one thing, does it do it or not? That's really all that is. And then start building in. I want to figure out how to add sensors in for game dev, because the real plan for all of this is to learn how to create a game, like an arcade game, or like the Mad Pod Race, or anything else like that, and then build an evolutionary algorithm to play it and beat it, or at the very least survive indefinitely, or at least a really long time. So that's what we're going to do. So GGEZ, I know GGEZ, I've worked with it a long time ago, although since the last time that I booted it up, GGEZ has switched hands. It is no longer maintained by IceFoxen. It's now by two people that IceFoxen gave it to. They're continuing to work with it, so it actually has like things happening. It's no longer just sort of simple anymore. You did Flappy Bird AI in Unity a couple years ago. Not sure if it was correct evolutionary learning, but hey, if it works, like that's a good thing, right? There's always learning and getting it to work. So we can do Flappy Bird, like that would be a good one. An Infinite Runner jump game could also work. Like if you really think about it, Flappy Bird and Infinite Runner is just the same thing, except you don't have a floor. Like that's all it really is. Any arcade game type thing could be really great and a lot of fun. So let's jump in. Not Bevy. No, I'm not going to do Bevy because Bevy, well, okay. The real reason, I don't know Bevy. And I don't want to spend too much time learning Bevy as opposed to learning this thing. And I know we can just get a really simple thing. And I don't care about graphics. I don't care about like a ton of things on the screen at the time. At least I don't think I do. We can pivot to Bevy later once we need to. Yeah, that's the big thing. Is there an end goal? The end goal is I want to build something like asteroids, and then I want to create this AI, this evolutionary algorithm to play asteroids. When I say asteroids, I really just mean any of those arcade type games that have the same complexity of asteroids. So, you know, Pong, asteroids, Breakout, Tetris might be a little bit tough, but like that would be fun too. I know that's a little bit harder to code. there's like any number of like action games is a lot of fun. So I want to do that. Now it's both really cool looking when it's like happening, right? Like I want to create that and it's just fun for me. I also feel that this is good for business, like putting on my Brooks Builds business hat, saying like, hey, look, putting all that stuff on the screen and like having it like learn and grow and get better is pretty freaking cool, right? Like at one point in time, I had an idea. This was years ago, of like, okay, what if I learn how to do that? And then I just like go to work and then leave my stream up and then an algorithm just learning and just like continuing to improve, and people can just like stop by to take a look at how it's doing, or they just keep it on their screens like, oh, look, it's over here, and going, you know, it's getting better and better and better. I never did that obviously, but like, hey, there's something to be said about watching something grow and learn after you created it. Goku, hello, how are you doing today? And because we are learning, let's do a Rust update, get that going. It is hat time because we are exploring. Okay, so we are brand new project. So cargo new, this is gonna be a binary project. We're gonna call this just exploring evolutionary programming. And GGEZ. Okay, so I need obviously GGEZ, so we're gonna do a cargo add GGEZ, and then also I want to see that this is the version of Rust we have. Nope, this is the version of Rust we have. Oh yeah, I already apparently installed it, so that's good. So that's 093 too. So this is versions. Tech. So we have Rust, and then also we should probably just say check okay. So let's go ahead and get us going. Now it has been a while, so I probably need to go look up how we set up GGEZ and get that going. That is small. Okay, so the first thing is that we're gonna have this main state here. I'm gonna build this in a kind of okay way. So let's go into our source. So we're going to have our main state. So that's what the first thing we're going to do here. So pub struct main state. This is basically the game, like the game state. And we're not going to have anything in here to begin with. And then that's it. Now they suggest we impl like a new on it. I don't know if it's going to be that important for us to do. We don't have like a location for anything. However, that being said, like probably creating like a new for it, because we probably will need to do something with it is going to happen. So Impl main state. Okay, so something really simple like that. Now we also need to impl event handler for this main state. And we can apparently set what the error is, or we can leave it as default, I think. Okay, and if you've ever used anything like processing or most game engines, P5.js, something like that, it's very similar here. So we have an update loop here with a context. So I always like to actually just call these contexts. And then that returns a context and it returns this game result. We're not gonna do anything here, so right now we don't have anything to update. And then we have our draw. So this is gonna be like actually drawing something to the screen, which again, let's just go ahead and update that. You're gonna yell at me that you're not gonna be used. I guess we'll underscore you for now. Quacky, Cookie, hello, how are you doing today? Is that hat from Safari? That's the idea. It's supposed to be like a Safari type hat that we're on exploration. We're going to explore around. I actually did consider getting like a pith helmet type thing, like the one you see people like exploring in out in the wilds, at least in the olden days, like anthropologists. So I decided not to do that eventually. Okay, so are we gonna catch some bugs? I hope we don't create any bugs, but we might. We are currently going to be exploring evolutionary coding, which we are very new at. So it's going to be interesting. Okay, so that is creating our state. Back to you. We'll do all this stuff in a little bit of like actually just drawing a circle. And then, okay, so in our main library, we're going to... We need to create a new context using the context builder. Okay. Now the context equals, okay, so actually it's going to be this context event loop. So really we're going to hit context and event loop. Equals, and then it's going to be context builder like that. Let's make this, give myself some room here. Okay, so new, and then I think we can just go straight to build. We'll unwrap. And you're upset because you need, oh, a game ID. So like, what's the name of the game? What's it going to register this as? This is, we'll just call this exploring evolutionary coding. And then author, Rick Circuit. Okay, that gives us those. Then I need to create our state. And then we're going to do event run and then pass it the context, event loop, and state. Okay, so you require a mute context. So a context, the event loop, and our state. which also needs to be mute. And then I think that's it. Does not need to be mutable? Really? Okay, I guess. Okay, no errors. So let's go ahead and run this. So if I do cargo run, there we go. We got our initial game. You could barely see it because it's black against black, but I can move it around. There's our window. It's not really got anything in it. We can change that. Also, it's pretty small. So we can create a circle. We go back to our library here. Okay, so it actually shows us how we can do this. So we're going to create a graphics. You want us to create a canvas. And then we draw stuff on that in the canvas finish. Okay, so we need to create a mutable canvas with graphics canvas from frame. Okay, so this will be graphics canvas from frame. You take in the context, which you need to be no longer that. And then, okay, so this is going to be clear. Will set the image initially to the given color if the color is provided, or keep it as it is if it's none. So right now I think it's black, but we can just set this to be whatever color we want. So I could set it to be white and just blow all your eyes out. Or we can just continue and just say, okay, you be, I guess this needs to be a sum. I want to say that there is a constant here. Let's see. What do you need? Oh, that's it. That's all it needs. Okay. So you're probably gonna yell at me because you don't know what that is. Oh, okay, fine. There is a graphics color black. That's what it is. Okay. I'm gonna move this over to the side so I can just check a look at it and don't have to go back and forth. If you want to take a look at GGEZ yourself, here is a link to the website that I'm using. All right, so we create the canvas, and then I can create a mesh. Oh, we're going to create, just like them, we're going to create a circle. So we're just going to say a circle. It's going to be equal to graphics mesh, a new circle. It takes a bunch of things here. Okay, so we're going to give it the context. Actually, a reference to the context. We're going to give it, oh, the fill mode. So under graphics, there is a draw mode. And then under that, we want a fill method on there. So I want to fill it in. Otherwise, we can just get the outline for it. Then I tell it its location, which this is super interesting because I'm going to say its location is 0, 0. And we're not going to use a normal vector. We're going to use a glam vector, which is re-exported from GGEZ. And so we're going to set this to be 0, 0, 0, 0. This next thing is going to be its size, so how big it is. They're saying 100, so sure, we'll just go with its radius 100. The tolerance, which the tolerance is how circle-like it really is going to be. So like how blocky or not blocky it is. This number is an F32 and can change. And then what the color should be. So let's do color. Let's not do white. Let's do cyan. That should be pretty good. This will be okay. So that creates a mesh for us. Now we can do we can take this. Take this canvas that we have, and then we're going to draw the circle. And then here we're going to give it, so it's these parameters here. So there's a bunch of stuff we can do. One of them is we could just give it a vec2 new, but we can just do a draw param. We'll give it a default. And then I want a destination to change it to a vec2. And then let's put it over by like 100, 100. So 100.0, 100.0. So it'll be not like center in the top left of the corner. And then that's it. That cannot fail, I don't think. What are you upset about? Oh, this needs to be mute. Can I just do that then? Yeah, I can just do that. And then you are upset because cannot mutate immutable variable canvas. Oh, you need to be mute. Okay, and then finally at the very end, we need to do a canvas finish and hand it the context. And then we're okay. So if we rerun this again, I don't know if you can see this well, but this is not a pure circle. It's like it's not full circle. There's some like straight lines across it. That's because we gave a 2.0 tolerance. That's not a circle. Here, we can fix that. If I do, I think a 1.0 is enough for it to become more of a circle. Asitsu, also hello. Nope, that wasn't good enough. That's more of a circle. Okay, so here is my idea. I want to create our evolutionary bot to do like we had a single dimensional evolutionary bot, evolutionary algorithm previously. The idea was that it just created it figured out what a string was that I wanted to figure out. That was it. If I say that I wanted it to jump up and like hit like above a certain line, or I wanted to like, I don't know, hit like a very specific, like, you know, to move in a very specific way. Like maybe I want to have it, oh yeah, we can make it, I can make it go to the right and then bounce off. And then, but I want it to go exactly perfectly and then just stop right at the edge. So let's code this up to work sort of like on its own. Now I can't really make this like stand up in front of everything, But I figure the next best thing that I can do. Startup Builder, hello. How's it going? How's the education project going? It's going well. We've I've been doing education type stuff in the morning, and then we're doing exploration stuff in the afternoon. So right now we're exploring evolutionary coding, which is fun. How are you doing today? Okay, so I want to be able to give this an initial velocity, just sort of like a kick on it, and I want it to like move to the right. So that's gonna be the first thing we're gonna do. So I can also do a cargo watch on this. And that will just kick this up whenever we make a change to it. So I can just flip away. And okay, how am I going to do this? I want to, we're not going to do a circle like this anymore. Now that we know that these things are working, I probably want to create, oh, taking your bike to the train station, bike safe. We're going to create an element. We're going to create a new file for this. What am I going to do? I'm going to create this as like a my game entity, like my main entity, my player. Let's create it as just like an entity right now. So entity.rs. Now we're going to have a position. I don't know if I need like these to be public or not yet. So we're going to have a position. We're going to use this as like a vec2. Oh, I need to. Where are you going to go? Yay, you went into the library. Excellent. Okay, that's what I wanted. Entity. Okay, so I want import vec2. Okay, so we have position. I guess like we'll start with that. We'll just have a position. And so this will start with an X and a Y. And in our main library, we are going to house our main, we're going to house our main entity. I guess, let's see. So we probably want to store them all at the same starting position. So let's put this in like 100. I probably want to make this a little smaller, like maybe cut it in half or maybe even a quarter. I bet if I put it down to like 25, it'll work. So if I do like 25 from the left and I do maybe 25 down is fine for this too. So just like very close to the very top, and that should be fine. Okay, so that gives me that, and then you are entity. Now this won't actually show yet, so I need a way to draw this to the canvas. So I need in entity a function to create the mesh for this. So we could call this draw, or maybe we can call this render. We'll need the context, which I don't actually know if I need it to be mutable. I think it just can be a reference. And I want to create a mesh for this. So here, we're just gonna do a mesh. I think a circle for this is gonna be fine. Okay, so we need our context, our draw mode. We can fill this. Okay, so it's point. This is gonna be just a vec2. What's next? Then, oh, this was the size, I think. This was the tolerance. We can do E0.1. And then this was the color. I guess we can also set the color up here. It's going to be a color. We can start with just making this white. But obviously we can now customize that pretty easily. Okay, so that returned you, and then you need, you're gonna return a result. So actually I want to return not a game mesh, but a game result with a mesh, if it's okay. Okay. Hello, how are you doing today? You have been making a GGEZ video because you're recently interested in it. Nice. If you want a lot more GGEZ, I have a bunch of stuff from a while back. So if you go back into the history, I have a bunch of GGEZ stuff. You can sort of like actually see me make things with it. And we made like a bunch of games. It was fun. Okay, so that gives me the render. Now I have this position here. You're definitely going to need to be public. So back to my library. I want to we're going to do canvas draw. Okay, so we want the drawable. So this is going to be a reference to the self.entity render, in which we hand it a reference to the context. And then we also hand it, what was the other thing we have to hand it? Oh, the params. So the draw param, default, destination, self.entity, position. Okay. Can I not do that? Job was not satisfied. Oh, right, because you implement a result, we have to question mark it. Okay, so that should work. Here is our circle. Oh, nice. Okay, you've seen some of the vids. Excellent. Yeah, so we're going to be using this for exploring evolutionary coding now. So I'm not going to be making like probably a full game yet, but maybe in the future. I kind of don't like it up there. I kind of want it to be like part way down. So let's just set our position. We actually have that in here, right? So our Y, let's just make this like 250 down. And then that should, yeah, that's good enough for right now. Is this going to bother a bunch of you that it's not centered? It's going to be fine. When we eventually do the evolutionary thing, I think what I'm going to do is I'm going to have them, everybody in the same, like if we have like 10, I'm going to put them all in different areas. So that way we can watch them get close. So I'll just start at the top left right now and it will be fine. Okay, so I want it to move to the right. So what we can do is inner entity, we can have a velocity, which is going to be a vec2. Now, do they have like a 0? All zeros. That's probably what I want. Now mark the circle stay in the same position as you move the window. Oh, I have seen those things all over the internet where like you're moving the window and it's changing position, and then even like you move it like another screen, or like you have two windows and you move them around. That's pretty cool. I haven't like really sat down and thought too much about like how it's being done, but I can't imagine it's anything other than like a shared back end with multiple clients like getting the data and like sharing it and then figuring it out. Like it's probably more tedious than difficult to code, but it's still impressive to look at. I'm hoping that what I'm working on is gonna be impressive too. Okay, so we start with an empty velocity, and that's obviously not going to do anything, right? So I want to kick it with an acceleration. So we're also going to have an acceleration. Okay, so we have a velocity and acceleration. That's great. Still not doing anything. I need a method now. So when I initialize this, probably not every single time, I just want to hit it once. And then I want that to be like a kick and start having it move. So we're going to have a pub function, I guess like accelerate. There's an official name for this when you like, apply a force. Apply a force. And we're going to take in a force, which is another vec2. Yeah, vec2. And I don't need to return anything. So we're just going to say self dot acceleration plus equals the force. And that's all we're going to do. So we have just something to apply the force. And then in update, so then we need an update. We're not going to return anything. We take our acceleration and we add it to the velocity. Then we take our velocity and add it to our position. And then we make sure to reset the acceleration. Can I do times equals? Do they have that? They don't have that. Okay, so I just want to reset this. So let's do a vec to 0. So reset that to 0 at the end of the update. Albert, you're back. Welcome back. Okay, so that does that. Great. And then now to make it actually move, I need to, in the main library, we create this entity. Let's make that mutable. And then we're going to kick the entity. So we'll do a let. So like we want to force. I want to kick it to the right. So that's going to be just an X. Let's do a like 1.0 and see what that is, and 0.0. We're going to say entity.apply force, the force. And that's it. Oh, and then an update. We're going to do self.entity update. And now our entity is now moving to the right. Excellent. Of course, it doesn't really do anything. It just goes off the screen into infinity. In fact, if I leave this up, it will eventually crash once it overflows the F32X. So let's see if we can update this to bounce off the right edge of the screen before that happens. So in update, there's like a bunch of things that I can do for this. I can have the entity be aware of like the size of the arena, or I can just have it be aware here. I kind of like the idea of being aware here. So let's have the arena size. So the arena, maybe we could just call this is our full width, is an F32 and a height. I don't really need a height for this, at least yet. Now our width is equal to, I don't know what this width is, but I think that if I take in a context, I think I can get it from there. So can I say context? Oh, wait, maybe I can get it from graphics. Oh, okay, so they don't want window from there anymore. I wonder where I get the window. Oh, but you know what we can do? We can give it, we can just do this here. You can just do width, F32. Sure, we'll just store the height as F32 too. One of your dreams is to become a train driver, so you sit all the way at the front of the train. Do you think that they would ever just let you go up there and ask? Like just to sit and do it? Okay, so you need to know the width and the height. There is actually a way for us to set this and figure it out. So let's do our width is going to be, let's make it like 1200. And our height doesn't need to be that high. Right now we could just make it 600. And then before I build this, there is a, I think it's window mode. This takes in a window mode. Dimension, set the window's default size. Okay, so then an X and a Y. So this is going to be width, height, and then U, we pass it in the width and a height. I did the colon thing again. Why am I suddenly doing this? It's like twice today. Okay, so that's our new sides. It's a little bit wider. I think it's about the same height. But okay, that's good. Now that we know how wide this is, we can, in the main library, in update here, check to see if it bounces and then have it bounce. So let's go add a bounce to our entity. So pub function, call it like bounce X. So if we bounce X, that means I need to reverse our X. So that will be self dot velocity dot X times equals -1.0. So just reverse it. Obviously that's not going to do anything yet. So we're going to, after we update, now let's find out if we're passed. So if self dot entity dot position dot X, if that is greater than self dot width, then self dot entity dot bounce X. Okay, so now this should, once it reaches the end, just bounce back and start heading back. You prefer having your back towards the front, really? So you like it going, you like sitting backwards. I'm not a huge fan of that. Okay, we bounced, but I don't know if you noticed, we bounced after it reached the center of the circle. So really what we need is to know if the middle of that has hit. And so we need to know if the position X plus half of the size, so plus self dot entity dot size, oh, which you are not public. Divide by 2. Okay, so get half of that and then check there. So now if the right hand side hits the edge, it should bounce back. Oh, okay, I get it. If there's emergency stop, that stop retains you. That does make sense. I feel like that didn't work. I feel like we still went halfway through. If our position at X plus this is greater than self width, then bounce. Did I save everything? I think it's saved. Okay. So if our position X is plus half of our size, do I just want plus size? Oh, wait, is this already radius? This might be already radius. So then just our size. Okay, that makes sense. You get a better sort of like vision of what's going on the train. There we go. Okay, so now it bounces off, the right-hand edge bounces off, and it heads back. But of course, the bots will never successfully do this because I need this to like slow down eventually. So we need to apply a friction. So a friction is more of like a global world thing, right? So let's add this in here. So we'll have a friction. That's going to be an F32. Now let's set this to be like 0.8, just ripping straight from, I think it was 0.85, ripping straight from, what is it called? The Mad Pod Race. And then we'll just add this in here. And then in update, we'll probably need to pass in this friction. Oh no, we apply this as a force. Yeah, I need to remember how to do that. I think, how do you apply the force as a friction? It's I'm just gonna multiply. I multiply the current. I multiply the current velocity by this. That gets me, oh, this thing, then I reverse it. So I then reverse it, and then I apply it as a force. Okay, so let our friction force is going to be our self.entity dot, oh, we don't have a velocity. So velocity times. So in this case, I could set our friction to be a vec2 to make it a little bit easier. Okay, so friction force is going to be equal to self dot velocity. Oop, nope, not whatever this was. Okay, so self dot entity velocity times self dot friction. Do you not know how to? Okay, you know how to do that. So that gives me a new vector, and then I want to reverse that. So will you let me do that? Can I reverse? No. Can I multiple? This doesn't you don't have like a multiple I'm concerned that they don't have it for a scalar. I don't think I can do like -1 to reverse that. Oh, okay. I think they actually do. Okay, so then we do that, and then we're going to say self.entity, apply force, our friction force. It just stops immediately. It doesn't have enough kick to it. So let's update our force and let's kick it a little bit harder. Let's kick it by 100 and see how much that is. That seems to be too much. I'm concerned that our friction force is way too high. Can I see what this is? Let's debug our friction force. Okay, so our friction force starts off with 85. Oh, okay. So hold on. I wanted this to be let's see. So we did 0.85. So when I multiply 100 by 0.85, that becomes 85. Right. That's too much. I probably want this to be like significantly smaller than that. Maybe like 0.1 or something like that. So what if I change you to 0.1? Okay, that's not too bad. That's still like, that's a pretty, I kicked it with 100. It's really fast. That's not fun to look at, but it is affecting. So I probably want to like add in a few more zeros. Now I could get like the delta and do like a bunch of stuff with that, but I am not going to be doing like proper game dev stuff with this. So yeah, let's just decrease the friction until it feels right. Okay, that's better. Now let's not apply it 100. Let's give it something like 20. Okay, that looks pretty good. Nice and smooth. So we know the answer is going to be less than 20, but probably more than 10 because we didn't get all the way back. So that's good. I don't need this debug anymore. So, okay. Now, what I want to do is make it so that if it hits and stays, I want this color to change to be like, you know, red or green to like show like, hey, we got it. Is that right? Do I care about that? Or maybe I don't care at all. Maybe this is like what we have. So let's go ahead and get rid of all of our warnings. I am going to use height. So I'm going to leave that one here. That's it. Okay. So now, okay, 341. We got time. Let's begin starting to set up the evolutionary code part of this, which I think we probably want to do in a separate crate, sort of inside of here. So I'm going to create a. I'm going to do a cargo new evolution. Like what bots? Maybe bot. I don't know what I should call this. I'm going to call it bot. I should probably not call it bot.rs. Okay. It's called bot. In my cargo.toml. Ooh, workspace. Okay. Workspace. We have members. Bot. Okay. So now I should be able to program our bot inside of here, and then they're going to be completely separate. And then I'll have to figure out a way for it to tell it what to do. So in the meantime, let's go find our code from yesterday. Okay, so we have a bunch of stuff. So we have things like create chromosome, but if we look out at like in general what we're doing, we first have to figure out like what the proper answer is. Like what is like right in this case. And right in this case is I want it to be exact. I want the position to be exactly touching the right-hand wall, not bounce like not hidden enough even by 1 pixels. I want it exactly at that point. So if we figure out, so if we go to our bot main, so let like a winning position, like answer, like winning position is going to be equal to, so whatever our width is of this entire thing, minus essentially 25, I think. That's going to be 1200 minus 25. Yeah, so 1200 minus 25 makes that 1175. And then you need to be in F32. You must not sleep in the train, but you're a bit tired. I don't know. I'm not like super loud or something. So sorry. How long is your train trip? I'm going to keep this over to the left also, but if you want to follow along, here is the code from yesterday. Okay, so then next is, okay, a chromosome size. So the chromosome size, now that, I don't know if I need to set what the chromosome size is for this. Because like we're not creating a string, we're creating a velocity that it's hitting. You're scared of missing your stop? My phone usually lets me, like, gives me a warning or alert. Like if I tell it like, hey, in maps, like tell me when to go, it will it'll yell at me. So maybe you could do the same thing. Okay, I'm gonna skip chromosome size. Okay, population size. That's gonna be next. It's going to go with 10 again. Okay, so we're going to create a population. So that's going to be our first thing here. So in bots, source, that's We'll have a create population. Obviously, we're going to take in our population size, which is going to be probably a U8 for right now. And we're going to return a vector of, what is this? Does this need to be an entity? Do we need to create an entity, or is it actually going to be something else? I feel like this is really just all you are numbers. How are you going to, how is this going to know to, okay, so if I'm just doing this, like a string, when we did the crossover and wait, was it crossover? Yeah, when we did the crossover, we took like the first part of A and the second part of B. But if it's just a number, like X, how is that going to work? Like all this has is a force. And a force is just a number. So this is even simpler than like the string where I'm just taking like half and half. I guess maybe it goes halfway between the two numbers. Maybe that's what I do. Yeah, that might work. So I feel like I want another file here. So we're going to touch, this is going to be a entity, like this is going to be the bot entity, so an individual. So all you're going to have is a force, which is going to be an F32. And really, we should probably just like for future proofiness do like a force X, and that's an F32. And so you're going to return a vector of individual. You're not giving me any help anymore. I have errors. Expected type. Okay, are you gonna, oh no, async job failed immediately. Oh, that's not good. Individual not found. Can you find it? Yes, okay. All right, we're getting help again. Excellent. Okay, so create a population. We want to create a population with the size. So I want to probably pull in rand. It says cargo add rand. I probably don't put that here. I probably put that under an individual. Forgot I need to restart because I need to figure out how to do that with Helix, because supposedly I'm able to make Helix like recognize I installed something and that I don't need to restart it. Okay, so import U, that gives me a thread range. I want to create a random force X, so let our force X is going to be, let's gen range between 0.0 through, we know that 100 is way too much, but we'll go ahead and set it to be up there. Okay, so that will give us U. So I want to do now a 4 in populations, I guess a 4 in 0 through. I'm gonna do a let population. Okay, so back to main. I probably don't need to like keep on like running that with watch every single time I save right now. Okay, so winning position, population size. I guess then we create the population. So let mute population is going to be equal to create a population and the population size. Okay, so we have that. Next up. Now it wants me to create the, okay, the answers. Like these are successful. So these are, I want to know the winning, like if we've got the successful, so I don't actually think I need to have like the answers in here. I think it might be easier for me to track like on the individual, like what is my end position? So like if I have like the end position, if that, the end position X, then I can track that to see if like that's winning or not. Okay. And I can, I guess, have, we'll create a method for this later. Okay, so our graded retain percent. Let's just set it to be exactly what I had before, but that's obviously something we can tweak. Oh, you arrived? Excellent. And you didn't fall asleep. Or if you did, you woke up in time. Glad you made it. Okay, so we got that, and then okay, so that's the non-graded retain percent, and then oh, I thought it was interesting to count the generations so we can like figure out and like see what's going on. So let's just do let mute generation count, and then we'll start with one generation. Okay, while answers is empty. Okay, so while we don't have any, oh, that's the reason why we have answers as a vector, is because then I can, let's just do an infinite loop. What can possibly go wrong? So we'll do an infinite loop. And I need to not forget an exit condition for that. So we're going to have the grade. Oh yeah, so if we check the grade, if on the individuals we have our end position, we could also have a grade. Or no, a score. And you're going to be an F32 between 0 and 1. Your score starts with 0. But we can check to see pub function like success. Oh, so last night I woke up in the middle of the night and I checked out and the lights were off. So they do turn off the lights around here, but you couldn't tell because all of our neighbors, it feels like, keep like floodlights on, Christmas lights are on, like just overnight, like even at like 2 or 3 a.m. So it's like super bright out here. Niank, hello, how are you doing today? So let's see, this is more of like success. Like I want, oh, we can get like, I can just make this public. And so we could say at the bottom, so if we'll have to loop through, so for individual in population, we'll just iter for right now, and we can change that to a mute. If the individual dot score is equal to 1.0, and it has to be 1.0. I don't know. Well, I have not watched very many French films, so unfortunately I don't get that one. Okay, so if we found that, then we're done, right? So we want to, and if I break out of the for loop, that doesn't end the entire thing. So I just need to know like let mute like found, like finished. let's put this over here. So equals false, which in this case, we might as well then just change this to a while not finished. Okay, so if that, we're going to do finished equals true. I will store that. Let me see if I... Yeah, okay. I will store that away so I can, we can maybe watch it. We don't have Netflix, so I don't know where I would find it. But I'll keep it on my backlog of things to watch. I would assume it's good, right? Okay, so if your score is good, okay, so then let's see. Population. Okay, so I do a generation and I recreate the population, right? And so generation comes from the main library. And this is where we do our selection. Okay, so it's an old film, but very good. Okay. What could possibly go wrong with an infinite loop comparing an F32? That's true. Wait, can I do partial equal? Can I do is partial compare it gives me like an ordering equal. That's not what I want. Oh, equal is partial equal. Okay, then that should be fine, right? Like it should totally be fine. Of course, you're right. We might have an infinite loop. I think we did the exact same thing down below here too. But okay, so we do our generation. Okay, so we're going to start with a generation. And then this is going to return a new population. So that's going to be a new vec of individual. Let's see. Logain, hello. How are you doing today? What am I doing? You skipped all the live? Yeah, we're working on evolutionary code. If you're looking for a more rusty way, you could filter, or maybe there's a find any. Oh yeah, that could be work. That could work. That could work. There's a float compare crate. I don't want to have to pull another crate for that. That seems silly. I do like the idea of the float compare. So let's say I don't do this. We'll do a if let's see. Okay, we do if I want to know exactly what the thing is, let's see, finished, successful. And we could just have this be a vec. And this is going to be a vec of individuals. I kind of like this idea a little bit more. So a vec of individuals, then maybe like the last thing we're going to do here is we're going to say successful is going to now equal, and then we'll filter. I will go. Thank you. It's this is the, what is this? It's Pretzel Rocks, the how would I tell what? Oh, it's the lo-fi track. So far that's looking good. I'm enjoying it. Okay, so successful equals, we're gonna do our population, we're going to iter filter get an individual, and I want the individual dot score to be partial equal to 1.0. And then we'll collect it. And then this can be while successful is empty. Oh, come on, don't. I figured that this would work if it was a oh, I thought that would work. Hold on. Will you be okay? I think this will be okay if I give it a reference, because like they exist out here. Okay, so that should work. Then we'll debug. Actually, we'll just do a print line. An individual figured out the correct force. After generation count, generations. Okay, and then we can't forget to also implement generation count plus equals 1. Okay. All right, that's good. Okay, so inner generation. The first thing, we're going to do selections. So I'm going to just take the selection here. Actually, you know what? I can take this stuff and we're going to update it. So I'm just going to take this entire file, not copy, not paste into there, paste into here. I did not need to bring the tests in. Oh, nice. Okay, so we have you. We'll deal. Let's move these use statements up here. Okay, so create chromosome. I'm not doing that. We're creating an individual different ways. That's fine. Okay, so get score. Okay, so let's just start updating these. So in get score, we have the chromosome, but this is actually going to be the individual, which is going to be a reference to, and actually this is really just going to be like, we want to set the score, don't we? I want to set the score, and this probably happens on the individual. Like, I want to set the score on this. So set score. And then in order to set the score, I need to know its current position. So I guess that's going to be the position X, which is an F32. And then in this case, how far away it is probably what we care about. So if we take, I guess the other one is always the larger number. So I want the position X divided by, so we're going to do self.score is equal to position X divided by self., oh, if we have the end position X, okay, wait, we already know this. I just need to say our score is going to be self.end position X divided by the actual width of the target goal, which, so I guess this is going to be target X. And then that should give me a number. Is that right? What was I doing for score here? It was, yeah, okay, I was doing basically correct divided by answer.length as F32. Okay, so basically this should give me a number between 0 and 1, right? So if I say I was like, it's 2,500 to the right. Yeah, yeah, we might want an update for this, don't we? I guess we're going to run the entire simulation and then we update it. This is where like the transfer starts to like, oh, like, I'm not sure how this is going to run, but we're going to figure it out. Okay, so I want to, we set the score. Okay, so if I do update, like, okay, so the assumption here is that we've run a full simulation and everything has stopped. I think that's how this works. So everything is stopped, and then we calculate like how it did. So that means let's see. So our score, we have our target. I guess I'm gonna keep it set score right now, and then it might make sense to make that. Yeah. So like we have an entity, and then I'm trying to keep them separate, like names. Like this is individual, but this is almost like a player, like a bot, the bot that's gonna play it. And then we have like the entity, which is the actual like circle that's being moved by the player, by the individual. Okay, so let's say it's 2,500, right? And we got not anywhere near. We got 100 divided by 2,500. Okay, so that works. And if we got really close, like 2450 divided by 2,500. Okay, so perfect. This should work. We should set the score properly. When do you set the score? You set the score in main, right? So in the loop, no, that happens in generation. When do we score it? Oh, in selection we score it. Oh, that's what it is. Okay. In selection, we get the score for each one, and then that allows us to sort it. No, so here's what I've got. If I run this, this is what we're eventually going to want to do, is I want the bot to figure out how to basically kick the ball to set the initial velocity to just come straight over to the end and read it. Now, I'm actually not telling it that it can't kick the ball, right? Like, it's actually possible that it can decide to hit it so hard that it bounces like 10 times and then rests on the end. Like, I'm not going to tell it that it can't do that. So it certainly could. I should probably actually allow it to start with a much higher. I'm basically saying like, hey, when I create this 1 to 100, but 100, I don't actually know how many times it goes past. Yeah, I can't get past the goal. It bounces off. So if I do like 1,000, I'm actually curious. If I go to main here and we say this initial force that we have, let's actually give it 100. That's a pretty big. Okay, that's a pretty big. I'm okay with giving it 100 now. Let's not give it 1,000. That's like not fun to watch. It would be fun though, interesting. It's like, okay, we hit it like 10 times, and then it like hits back. Oh, but it only bounce once. I don't have it bouncing back again. Okay, that's a good point. It can't actually bounce back because it never bounces off the left side. It only bounces off the right. So then it goes forever into the left, the negatives. So yeah, no. It's gonna be a lower number than this. The ball disappeared off of the left-hand side. Okay, so in selection, it does the scoring. Okay, so what that means is this get score, we just get rid of. We don't need it anymore. In selection here, we're going to take in, this is like, okay, so this is chromosomes, but like I have renamed this to, this is the entire population. So I want all the individuals. So I want the population, which is going to be a, this is going to be a slice. I think I'm taking ownership of this, right? So this can just be the vec of individual. All right, let's do some types here. So we'll take ownership of the population. Dayloop. You redeemed quack. We can do that. We can do a quack. Here, let's set that up. And that's a nice one. It's hat day. Yeah, we are exploring. We're exploring evolutionary coding. More Rust, more Gemini, more HTTP, more HTML, CSS, more breaking stuff. Yeah, that tends to be it. Okay, so we have a population. We have, okay, so where's my mouse? Okay, so we have our graded retainer percent, our non-graded retainer percent. We're taking that, and the answer. So this is the. I think we want to name this to be. This is the target, and the target in this case is an F32, and we can go further into like it's the target X F32. So we want to first, okay, you need to be, we want to mute you. Okay, so chromosomes. So this is our population. We're going to store stable by, okay, individual A, B. So really I want to do A, B. And then we're going to get the score. So I think the first thing we want to do then before we do, okay, so before we do the generation, we're going to loop through all of our populations. So we're going to do a population. You're already mutable. Okay, so population dot for each. So iter mute for each and individual. We're going to set the score, and our target X is that winning position. So okay, so we go through all of them and we set the winning position on it. Oh, you've done genetic optimization in production? It's fun? Yeah. It was fun just already with a like simple string example that we did, which like doesn't have that much graphically to it. So now we're doing it with something much more graphic, which should also be fun. Okay. All right, so we have our population. Okay, so we get the score, which means that now I do not need to get the score like this. Instead, we can just do it was B dot score partial compare to A dot score. Okay. So that's the first thing. We sort the population in place. Time check. Yeah, we're running out of time and there's a lot left to do before we get this done. So I think we're going to have to end it here, even though I really want to continue because like I want to see this work. But you're right. I need to go, and I don't think we're going to get like to a meaningful test of it and then have time to actually run it by within the next like 10 minutes or so. So what we're gonna have to do is end it for the day. Let's go ahead and just we have a bunch of stuff here. Okay, so I don't have any target or anything else. Okay, that's fine. All right, so git add. We already get to commit. Okay, so this is work in progress. We're creating the. I guess we're calculating. So like, I guess like porting the evolution functions. So that's what we're working on. Let's go ahead and push that up. Oh, I don't have a repo for this. Let's create that too. Okay, so this is going to be, let's learn evolutionary programming with, by making something visual in GGEZ. Public. Yes. 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 Okay, and that's not correct. I want you. Here is this code. If you all want to go take a look at it, there that is. I will also put this into the description. And then before I forget, let's just go ahead and pin this tab. So that's just available for me for future videos. So yeah, we're going to continue working with this. We're so I'm doing morning streams as sort of like the teaching started, like figuring stuff out like on the teaching side. So we're doing a U project right now. We're almost done with that, and then we're going to do something different and hopefully interesting once that's done, but that's like very different. And then here we're going to continue working on evolutionary coding on the afternoons. So that starts around 2:30 p.m. Mountain Time and then continues on. So if you're interested in U code, that will be tomorrow morning 7:30 a.m. We'd love to have you. Otherwise, if you're just here for this, tomorrow at 2:30 p.m. Mountain Time, and we'll continue with this one. Have a great night, Albert. Have a great night, everybody else. If night is coming up for you, or otherwise, have a great rest of your day, and I will see you next time. Bye.